This conference will now be recorded.
Okay, so this is where we are. Again, we have created a repository in Azure DevOps. So we started off with a project in Azure DevOps, then created a repository inside it. And in the repository, we are talking about different branches that we have. So we said we'll have a main branch, we have a develop branch, and etc. And then we were talking about how to protect these branches, meaning we're talking about an important policy called, or the important concept called branching policy, wherein we went ahead and established a couple of policies out here. One of the very first thing being I at least need one reviewer to kind of look at this change, or one reviewer to look at something known as pull request, review it, and approve it. This is something that I said. And then secondly, when I just go down, scroll down, there is something called linked work items. So for a developer or a DevOps engineer to make any kind of a change inside a repository, I need the work items to be linked. So I need someone to kind of give the work item, only then I need to go ahead and make this change out there. And there's something called comment resolutions, wherein we said that if there are any comments on the PR, then the pull request should not be allowed to get merged. These are the policies that we kind of looked at. And then I also said that there's something called include automatic reviewers, wherein you can automatically assign the PR to one particular person or a group of people who can go ahead and approve this PR or approve this change out there. So these are all the policies that we went ahead and configured on the branch. And coming to the branch, or coming inside the branch, yesterday I went ahead. I created, sorry, I created something called as a .NET framework code, and this is I said is a .NET full framework. This is a .NET full framework code out here. Something that I went ahead, I configured the branch, and I basically pushed something called as a .NET full framework code out here. Now, me being a developer right now, I also have another other kind of a project, which is a .NET Core. So I am a developer. I am working on two different projects at the same time. I have a .NET full framework code which I have written yesterday. Today, I'd like to go ahead and write a .NET Core project out here. So let's understand, let's come to the differences between that. Firstly, what I'll do is again, I'll use my Visual Studio editor. I'll use Visual Studio 2019, and then I'll just open up the Visual Studio. And yesterday, when I have written the code, I have selected a template called ASP.NET Framework. Today, what I'm going to do is I'll just do the same thing. I'll say create the new project, and from the available templates out here, I will just go ahead and select a template for ASP.NET Core Web Application. So I'm just primarily dealing with .NET at this point. Let's look at what are the other coding languages that we do have and etc. But at this point, I'm just looking at the .NET, the flavors that are available in the .NET out there, and let's understand this into a bit. Let's go into a bit of this and let's understand what is the real difference between all these things. Right? So again, I'll just type in ASP.NET in the search bar, and as when I do this, it'll just load all the available ASP ASP.NET applications that I do have out here. And I would like to select the very first thing, which is called ASP.NET Core Web App. Now, this is important. So, it's a core application to sample ASP.NET user page content and all that stuff. So, what I'll do here is I'll select this particular template out here, which is the first thing, or which is the first option. And yesterday, believe me, or yesterday, remember, I went ahead and selected this one, which is something known as a .NET framework. And today I'm going ahead and selecting something called as a .NET Core application. So let's go ahead and do that. Let's go ahead and select this out. Let's say next. I'll give a name to the application. I'll say it is .NET Core Demo Application, something like this. I'll say next, and I will use something called .NET Core 3.1 long-term support. This is the framework what I'm using. This is the model what I'm using, and I'll say create. So this is going to take a minute to go ahead and create this out. And once this is created, I already have all my repository cloned in my local machine. So if I look at my local machine right now, yes, that Azure DevOps, yes. Inside the first repository, I already have all this clone. So what I'm going to do is that I'll just open my VS Code and I'll just open this folder inside my VS Code. So let me come here into my VS Code and I'll say open folder, and I'll just give in the folder name here and I'll just open that particular folder up here. Select folder. And once this folder opens, I just have the readme.md file. I have the .NET full frame. I have the .NET full framework application that is listed down here, and this is now being version controlled by Git. The Git is able to track all the changes to this particular file, and it's able to tell that I am working on a branch called develop branch. So this is where I am. So what I'll do here is that great, I have a .NET full framework application here. Let me go ahead and this is the .NET core application. Again, I'm just doing a right click. I'm not doing anything. It's just a very simple template that I've created. I'll say open folder in File Explorer. This will get me here, and this is the name of the application, or this is the entire folder in which my application is actually present in. And I'm just copying the folder, going into, let's say, the repository, pasting it out here. Okay, let's give it another try. So I'll just go ahead, copy this out, and I'll just go ahead and paste it out here. And done. So I pasted the entire folder inside the repository, inside the folder where I've cloned the repository. And remember, Git, Git on my local system is tracking all these changes. The Git that is present on my local system is now tracking all these changes. So if I go into the VS Code, it's now able to understand that there is a new folder that is present right now, which is ASP.NET Core Demo Application. And there are about 67 changes that are actually coming in. There are about 67 changes that are actually coming in, and I am working on a branch called develop branch. But as we stated yesterday, a develop branch is protected, it has policies, so I cannot commit directly on top of the develop branch. So what I'm going to do is I'll now create a new branch from the develop. I'll say this is feature.NET Core. I'll say this is the develop branch from which I want to create it, and I have the branch created, and I'm now working on that branch. So feature-.NET Core is now my checkout branch. This is now my checkout branch, so I'm no longer working on the develop branch. So what I'm going to do is I'll go into the source control, I'll stage all my changes again, And once my changes are staged, I'll just go ahead, enter a commit message telling that this is a .NET Core application and commit it out, and then sync my or publish my branch. What this is going to do is that this is going to take all the changes from my local machine. It's going to push it back into the Azure DevOps repository. It's going to push it back into the Azure DevOps repository. So once if I go here and once if I go into my branches, I have the feature.NET Core branch that is getting reflected here. So what I'll do is the next thing is that I'll now go ahead and create a pull request into the develop branch, and I'll just go ahead and say I need a work item to also be linked. So I'll just go ahead and take an existing work item, which is yesterday what I've created, just write .NET Core application and merge it into the develop branch. I'll say create. So I now have a couple of things. One, I have all the required checks that are succeeded, meaning I have the comments result, I have the work item linked. There are no merge conflicts, meaning when I raise the PR, no one else is raising a PR at the same time, and no one else is making the same change. And I need the contributor to go ahead and approve this out. So what I'm going to do is I'll say set to autocomplete, delete the feature after delete the feature .NET Core after the merge is done. So set to autocomplete this out, and I'll just wait for my lead to go ahead and approve this out. So if I go here into the Azure DevOps as this person, as the contributor, let me sign sorry, let me sign into Azure DevOps. I'll say RBAC contributor. And I will go into the project as the contributor or as the approver. And if you look at the pull request right now, I have a pull request that is waiting on my behalf, which is just updated now. And right now I can look at number of files that are coming into the repository. And if I'm good with all these things out, I'll just go ahead and say approve. And once the approval is done, the pull request got merged, the merge is complete, and the branch from which the merge happened got deleted. So if you look at the branches right now, I only have the develop and the main. So I'm maintaining or I'm making sure that the repository is clean, and I'm just cleaning up all my unwanted branches. And if you look at the develop branch right now, it has the ASP.NET Core application. It also has the ASP.NET Full Framework application. And both of these things are now inside the repository. So this is where I am, guys. So any questions till here? Anything anyone till here? Anything anyone till here? Any questions that I can take? Is everyone able to follow this procedure, guys?
Uh, Hello, Kiran. Actually, I did not attend yesterday's class, so when I heard the recording, I had a couple of questions for yesterday.
Okay.
So as a contributor,
Hmm.
we have added a comment on the work item and
Right,
has not approved it,
right.
right? But later
Hmm.
when we go back to the um, as an administrator account, the status there was showing as approved.
Hmm. So what did I do yesterday is that as a contributor, I commented and I approved it also. So what did I do yesterday is this. So if I just do a test branch right now quickly and take something like this, and let's say I make a small change here, and I as a developer is now going ahead and raising a pull request right now. So I'll just go ahead and say pull requests, and I'll say new request from the test branch into something called the develop branch, and I've updated this file, and I'll just say create. So as a contributor, what I did, or as a reviewer, what I did is that I came here, went into my pull requests. I see that there is a new pull request awaiting for my approval, but I see that this is the wrong line basically on which this is commented. So I'll say please correct line, something like this. I'll say comment, and I'll still go ahead and do an approval. I still went ahead and gave my approval, but there's a comment here. There is still a comment here, but my approval is done. So the reviewer has approved it out, but a comment is still in there. It's not yet resolved. So me as the administrator or me as the developer is coming here, and now I see that there is a comment here that needs to be resolved. I went ahead, resolved it out, and I said that this is done. I said reply and resolve. As and when this is done, the approval was done. I just hit the complete button and I deleted the branch out here. So the reviewer doesn't have to approve it again. The comment just has to be resolved. So once your comment resolution is done, your PR will get merged without the contributor having to explicitly approve it out. Does that answer your
Okay.
question?
Yes, yes. And whenever we complete the comment, or whenever we will send it for approval, the contributor or the reviewer will get a trigger in the inbox or the Outlook inbox or an
Yes,
email to
on
them,
the
right?
yes, they will get an email trigger out there. So for example, this is how the email really looks like. So let me open a Gmail account. Let's see if I have the Gmail account with me. Not this one. Let's see, add another account. And once I'm inside this, it should have something like this. So there are all these PRs out here, which says a PR is waiting for your approval and everything. So if I go into the email, like this is how the email will look into your Outlook or whichever mailing system that you're using. It says
Mm-hmm.
this is updated, this is updated, and this is required. So and this is the commit and etc. And if I just hit view pull request from here, it'll directly take me to the PR out here, and you can directly go ahead and approve this out. So every time
Okay.
you raise a pull request, there will be an email getting triggered.
Okay.
There will
Likewise,
be an
the
email.
administrator, yeah, likewise as the developer or the DevOps engineer also will get a email trigger when a comment has been updated or whenever it has been approved, right?
Exactly. Yes.
Okay. I have another question.
Hmm.
When you have pulled the develop branch into the Visual Studio in the
Okay.
second half
Hmm.
of the class yesterday, so it
Hmm.
was
Hmm.
being done on a local machine, right?
Right.
So the policies will also be applied on the local machine which was copied or I don't think so. That will be applied policies. The develop branch
Policies,
which was copied.
that's correct. So the policies will not be applied on the local, meaning you can still go ahead and commit your changes, but you won't be able to push them back into the repository. So when you try pushing it back into the repository on the same branch, it'll start throwing you error telling that the branch has policies and you cannot directly commit on top of it. So on a local developed branch, you can commit it. Meaning I have two things out here that I'm dealing with. One is the local branch out here. The other is a branch on the remote repository. On my local branch, I can still do all my commits and etc. But I cannot push the commit back into the Azure DevOps repository. And if I have to do that, I have to change my branch and come up with a feature. Does that
Yeah.
answer your
Okay. I
question?
got it. Yes. 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 Thank you so much.
Any more questions, guys? Okay. So let's come back here. And if I look into my repository right now, I have two different varieties of code out here, belonging to the same family called .NET, but two different varieties of .NET. One called a .NET full framework application, the other called as a .NET core application. But what is really the difference between it, and why am I explaining this right now? Because this is a pure development concept. But as a DevOps engineer, why do I need to really know about it? Now, the reason you need to know about it is because it is your duty right now. I mean, from this point in time, now this is where you are. So the developer has done his duty. He went ahead, committed the changes and etc. He's done with it. All the changes are into the develop branch. Now, as a DevOps engineer, you need to start working on the build and release pipelines because this is the core activity that we look into. This is our bread and butter that we actually kind of look into. And for me, whenever if some developer comes to me and tells that what, I need a build and release pipeline for my repository, all my changes are in there, the first thing I would actually ask is that what kind of a code have you pushed into the repository? Is it something like Python? Is it something like Java, .NET, PHP, Golang? What is the language in which you have developed the code? This is the first thing that I'll ask. Let's say the developer is now telling me that, okay, fine, I have developed the code in something called .NET. I will again go back to him and say that, what, agree, this is .NET, but depending upon the framework of .NET, whether it's a full framework or whether it's a core, I need to make sure to design my pipeline accordingly. So then what is the difference here, or what is the major difference between a core and a full framework? What do I mean by a core? What do I mean by a full framework? Let's get into it. So .NET again is a family of a programming language which basically is developed, is maintained by a company called Microsoft. This is, let's say, the brainchild of a company called Microsoft out here. And the very first version of .NET was called a .NET Full Framework. Now let's understand this, and we would need a bit of development bent of mind to understand what really happens out here. So I'll try my best to, kind of consolidate it, kind of water it down, and give it in as simple procedure as I can. Now, the first thing is that, just give me a second. Okay, sorry. Okay, sorry. I have a very, very bad throat today, so please excuse me there. So, the very first thing, as a developer, if I am developing a program in in something called as a .NET full framework, one thing I have to keep in my mind is that the code that I write, I'm writing a code, and this code needs to be deployed on top of, let's say, a server, or on top of, let's say, a Windows virtual machine or a Windows web application. Now, I can only deploy this code on machines that run on Windows operating system. I cannot deploy this code on machines that run on any other operating system like Linux flavors, like Ubuntu or something like that. I cannot deploy this code, meaning this code cannot run. This code doesn't have the capability to talk to an operating system like Linux. It can only talk to an operating system like Windows. This is the first major thing that I have to remember when I'm actually developing a code for an application which is running on .NET Full Framework. This is the first thing. Second thing is that, let's say that I am writing this code for a newspaper website. Okay, so this is what my requirement is right now. That I'm just developing this code for a newspaper company. So whatever newspaper that you see, the backend, the running code is something that I have written in our .NET Full Framework, and the requirement that the newspaper company has out here is that this newspaper has presence all across the globe. So what they want is that whenever a user is coming from, let's say, a country like US, the newspaper should be displayed in a primary language called English, because a lot of people in the US prefer this particular language, so they want it to be displayed in English. But we also have realized that there are a few set of people in the United States who also prefer languages like French, or let's say Spanish, and so on and so forth. So I also want my newspaper to support those languages. So what I told to the developer is that I want a button in my newspaper website which will talk something like convert or translate. Now, this button is just like when you land up in a website like which is written in Spanish or etc. Right? Google will automatically give you a suggestion here somewhere in the right corner that do you want to translate the language. So this button out here is just helping us to translate a language from a foreign language to a language that you understand. So this is what I need with my website, and this translate button should have an algorithm, meaning should have a code running in the backend, which will help you just do this translation from one language to the other. This is what I want. So as a developer, for me right now, the code is two things out here. One, the actual code that will help me display the news on, let's say, a particular website, the font and all that stuff, right? One thing is that particular code, which is the core area where I'm working in, which helps me in displaying the website, in, let's say, giving the images on the website, in, let's say, helping transactions being done on the website, all these things out. This is the core code that I'm working on. But I also have another duty, which is to include a translator. Even this is a kind of an algorithm, even this is a kind of a code that I'll need to, or I need to basically imbibe, I'll need to write here, right? So I have two things out here. Now, the very first thing, this one is something, or this is the piece of a code which is very native to my website or very personalized to my website. So I need to write it from the scratch. So I as in a developer needs to write it from the scratch. But let's say this translator is already being used a lot. Like, a lot of websites are already using it. So I don't have to really do a lot of effort here. I simply have to go to the internet and just download the piece of a code which can help me write this. Meaning, they are something called as packages available in the internet, which will help me write all this code, or which will just help me for this particular functionality. So I don't have to really write this code out here. It's a smarter way of developing things out because it's already been developed, and I don't want to again write it from the scratch for the same functionality and waste a lot of hours. I just want to download this package, which is readily available on the internet, and make sure to use it in my code. So I am writing a code. So please observe this. I am writing this code. At the same time, I am internally telling my code that, you know what, please download this also. So please download it from, let's say, an external website or something like that. So please also download the package called translator. These are the two things that I'm doing. So I'm now writing the code. I'm done with writing all the code. I've written the code in plain English. So this is how my code really looks like. It has all these folders or everything basically. I also basically went ahead and mentioned what are all the packages that needs to be downloaded. Everything is something that I mentioned on my code. Now I'm just talking about one thing, or I'm just talking about one package. Just imagine that you have 10 different packages that you are downloading, which your code really depends. So for your code to successfully run, in this case, this code depends upon a package called translator. This is one of the very important packages that needs to be available for your code to properly run. All these packages that your code kind of depends are called dependencies. In a technical terminology, there is called dependencies. That's what, if you write a code here, if you write a code in the Visual Studio, this is what you will see. The very first thing is called as dependency. Meaning there are a few packages on the internet which your code will kind of depend on. And when you do a build of your code, meaning why do you want to do a build of your code? Because you have written the code in a high level language and you want to deploy your code on top of a server, and the server cannot directly understand this code. It needs the code to be converted into something called as binaries, zeros or ones. In another terminology, they're also called as artifacts. So you need to convert your code from a high level language to a low level language. And this process of conversion of your code from a high level language to a low level language is called a build process. And build is a two-way step. The first step called restoration. What do you want to restore? You want to restore your dependencies. Meaning you want to download all the dependencies, make it readily available for the code. So downloading the dependencies is called restoration. Downloading from external websites. So I'll say downloading from external websites. And the second thing is to build the code plus the dependencies. So the first procedure is to go ahead and make sure you do a restoration. Second thing is to go ahead and actually build. So even if I go ahead from my local machine, do a right click here and say build, the first thing that's actually going to happen is that it's going to try and restore all the dependencies my code is dependent upon, and then it's going to go ahead and convert the code plus the dependencies and make it readily available in a binary format. Now this is what has happened. First step went ahead and restored my dependencies. Second step went ahead and said, okay, fine, I have restored everything. I have built this out. This is a two-way procedure. So I am talking about a process called restoration and build. And guys, I request you all, please make sure to ask as many as questions. If you're not following, please stop me, because this is going to form the basis on what our job role really kind of depends upon. And now it comes here is that how do I restore it? How do I restore my dependencies? Meaning, how can my code restore these dependencies? The thing here is that .NET Core or .NET Full Framework out here, since you're talking about full framework, does not have the capability to restore dependencies on its own. It cannot do that. Yes, does someone has any questions? Okay. So .NET Full Framework does not have a capability to restore its own dependencies. It doesn't, or it lacks this capability. It doesn't have the power to go ahead and kind of visit an external website and download its own dependencies. It cannot do that. It needs a help from another tool, which is called a package manager, which will just do one thing. It'll just help the code to download all its own dependencies out there. And the package manager for a .NET Full Framework is called NuGet. This is a package manager for a code, or for, let's say, a code written in .NET Full Framework, which is just assisting this, or which will just go to an external website on the internet, download all the packages, and make it readily available for the code. This is what NuGet is actually going to do, and that's the reason this is called as a package manager. So what will happen when you do a build and restoration procedure is that it will go to NuGet. It'll .NET Full Framework code will talk to NuGet, and it will request NuGet that, you know what, I have these packages that I need, I have these dependencies that I need. Can you please go ahead and restore it for me? NuGet will visit a site called nuget.org, which is a very popular site to download all these packages and etc. So it says the package is downloaded so on something, and it says what is NuGet and etc. So it says NuGet is a package manager for .NET and all that stuff. So it'll go to this website, go into the downloads, and just download all the packages that is required by your code. This is what it's going to do. So what's happening out here is that even before my build and restoration process is actually beginning, my .NET Core application, or sorry, my .NET Full Framework application is making a call to a package provider or to a package manager called NuGet, and telling NuGet that please help me in downloading all these dependencies. So it's requesting NuGet to download the dependencies. NuGet is again going internally to another website called nuget.org and downloading all these dependencies, making it readily available for the build and the restoration process to happen. So this is what is happening internally in .NET Full Framework. Now, as you see, if now I look at the build process, it's not a straightforward thing. It has all these things out here. It it's calling NuGet, it's downloading all the packages, it's making it readily available, restoring dependencies, building the code, and etc. This is what it's doing. So what happens is that every time you build an application that is running on .NET Full Framework, it lacks this capability to go ahead and restore and so on. It's making an external call. It needs an internet connection. It needs a good internet connection and all that stuff. So this process is a bit slow. So there are a couple of downsides by writing code in a language called .NET Full Framework. A, it cannot run on uh, an application, or it cannot run on a server which does not have an operating system which is called Windows. So this code cannot run on an operating system which has, let's say, something like Linux or Mac or something like that. B is that the dependency restoration process is very slow because it needs to depend upon an external package provider, and it's doing a lot of things out here. So in order to address all these issues, Microsoft came up with another language, or Microsoft came up with another flavor of the language called .NET Core. Now, what exactly happens in .NET Core is that .NET Core very smartly addressed all the issues that were there in .NET Full Framework. Firstly, .NET Core is called platform independent language, meaning you can run the code that is written in .NET Core on an operating system which is either Linux, Macintosh, or Windows. Any flavor of Linux like CentOS, Debian, Ubuntu, anything is supported. Any flavor of Mac like Mac 17, 16, and a lot of versions of Mac are actually there. Your .NET Core application can run on any platform independent, or let's say any operating system independent of, let's say, the version it has. B is that the dependency restoration procedure is very fast. Reason being, .NET Core can make, or .NET Core can make sure to go ahead and download the packages from an external website without having to call a tool called NuGet. Meaning, the dependency restoration procedure is an inbuilt process for a code called .NET Core. The dependency restoration process for a .NET Core application doesn't have to do all these things. It doesn't have to call NuGet and etc. It does it in this step itself. It goes ahead to the external website, downloads all its dependencies, manages its dependencies, and etc. So it's a bit smart enough, and it's faster, and this is platform independent. Reason being, a lot of developers are now preferring .NET Core over full framework, but they are there are teams who are still working on full framework for obvious reasons, that they only want it on Windows platform and they've been using it since ages. They're very comfortable with it, and different reasons for that. So we need to understand, as a DevOps engineer now, this is where I come into picture, is that how do I design a strategy for a build pipeline for a .NET full framework versus a .NET Core? How do I manage it as a DevOps engineer is what I need to see. This is where we are actually heading to. And in order to understand the strategy, in order to design the strategy, we need this bare basic understanding. Just these differences on what this is and how can I build it and etc. So this bare basic understanding is something that we need, and that's the reason I was going ahead and giving a very brief idea on what .NET Full Framework versus a .NET Core really is. So any questions till here, guys? Are you able to follow this out? I'm trying to make sure that this is as watered down as possible. There are a lot of more differences between .NET Core and full framework, which we do not really need to delve into, because as a developer, if I was taking this class for a development team, then I would have kind of went ahead and shown what is the code, how do I write it, what is the difference, and etc. But as a DevOps engineers, we are good with this. Like, we should be good with this particular knowledge for us to go ahead and create the build pipelines out here. So any questions till here, guys? Anything till here? Anyone, anything till here? And believe me, guys, this class will form the basis of the build and release pipelines of what we're going to create. So that's the reason I'm just emphasizing on the importance of it. This is like really very important to understand this particular difference, so that we can design our pipelines efficiently. So any questions till here, guys? Anything till here? And one more tip that I want to give you all is that when you are especially working on a repository and you do not know what is .NET Core and what is .NET Full Framework, I mean, you don't really know the difference and etc. You don't want to go into the code and look at it. The easiest way to identify the difference is this. So for a .NET Core application, if I open up the folder and if I open up the actual folder that contains all this application, I will have these files called appsetting.json. These two files will be present to hold all the configuration that is required by the code. .json files is something which it holds in. This is the identification for a .NET Core application. Whereas when I come to something called a full framework, you will not be able to see a .json file. You won't be able to see that. There is no .json file here. Rather, it uses a file called web.config, web.debug.config, web.release.config. So if it's a web.config, then this is, let's say, a .NET full framework application. Like, this is like a rudimentary difference. Like, this is, let's say, for a layman like me, if who doesn't know how to write a code, if I just want to identify and if I just want to get my job done, this is the first difference I'll actually look at. So a full framework will have something called a web.config files, and a .NET core application will not have the web.config file. It will have something called appsetting.json file out here. So this is the main difference, or this is, let's say, a very simple difference on how you can identify and design your pipelines accordingly for a .NET core application versus a full framework application. So this is what this is, let's say, just a small tip on how do you remember this out. So any questions still here, guys? Anything that I can take till here? Anyone? Any questions still here? Okay, so what we're going to do starting tomorrow is that we are going into the build pipelines. So we are going into something called as pipelines out here. We are going to understand what is pipeline. So this is how it will look like. It'll tell what create your first pipeline, etc. And it has all these cartoons out here. So we are going to go ahead into the procedure of writing a pipeline, into the procedure of designing a pipeline, and we are going to understand how to automate the entire procedure, or how to automate the entire life cycle of the software development. So this is what we are going to do starting tomorrow. And please make sure to listen to this video again and again. Please make sure to write down your questions, and please ask me as and when you have something, because this class again is going to form the basis of the coming classes out there. And this is really very important to understand these small differences that basically are there between the .NET core applications and a full framework out here. So any questions before we close, guys? Anyone, anything before we close?
No, Kiran.
Okay, guys. So that's it from my end today. Then have a great day ahead, and we will meet tomorrow, and we will start with the build pipelines. Thank you, guys. Have a great day.